Hi, everybody. Welcome back to the session 2 of module 1 Building of Networks of Computer Networks. In this video or in this lecture, we are going to see about the definition of topology and what are the types of topology, their advantages and disadvantages, and what kind of topologies can be applied in computer networks, how hybrid topology can be applied in the computer networks. Let us quickly rush into the topic. Topology is nothing but it's defined as the fashion in which the nodes in the networks are connected. As we discussed in the previous session, we have defined what is a network, but the question comes is how do I formulate the network? When there are two nodes, topology is not going to be more significant because point-to-point communication makes it more simple. But in case of internet, which towards we are stepping in, we are connecting n number of devices. So how do we really connect this n number of devices is a big challenge. So there should be some normal or standardized procedure we have to formulate. The difficulty in communication can be eradicated. So topology defines the manner in which we can connect the nodes in the network. So based on the number of nodes you want to connect in the network, the topology can be selected. Fundamentally, the topology can be categorized into four categories. One is called mesh topology, second one is star topology, third bus topology, and fourth is ring topology. So we are going to see one by one in this video. So first is mesh topology. So mesh topology is nothing but this is the diagrammatical illustration of how a mesh topology. Consider we want to construct a mesh topology with 5 devices. 5 n devices. We start numbering from this 1, 2, 3, 4, 5. So the mesh topology, you can see that the link are basically one to all. If I take the station 1 or I can say this is device 1. So from device 1, all 4 other n devices are connected by separate links. So 1 to 2, 1 to 3, 1 to 4 and 1 to 5. Similarly, if you take your second node, 2 to 1, 2 to 3, 2 to 4, 2 to 5. So this is called as a fully connected mesh topology. So what is the advantage of this mesh topology is, in case if there is any link failure happen, say for example, if you want to communicate an information from station 1 to station 5. Of course, as per this diagram, we can see that station 1 is directly connected to station 5. Let us have a situation where the station 1 to 5 link is cut by something. There is a link failure has happened. In that case, station 1 should be in a position to communicate the information to station 5. So now it picks up the alternate path. So link is nothing but connecting two devices, but path is nothing but providing multiple links to connect to the sender to the destination. In this case, I'm repeating it. So link is nothing but connecting two devices directly. So 1 to 2 is connected by means of a link. Whereas when I want to connect 1 to 5 or 1 to 4, when there is this link failure has happened, then you are expected to use link 1 to 2, this link, then link 2 to 3, this link, and link 3 to 4. So if you want to connect through this path, you are using 3 links. So what's the difference between link and a path? So link is nothing but connecting two devices, whereas path is nothing but connecting the source and destination. It could be either can be connected either by using one link, or sometime if they are spaced apart, then we are forced to use multiple links. So what is path? Path is nothing but using multiple links. So the number of links that you try to use to construct the path will vary from the network to network. Okay. So the next thing what we have is the star topology. So star topology is mostly used in most of the LAN network where you want to have uh, one one link that you want to connect to. So this hub is an interconnecting device. It is a 4-port interconnecting. It is a 4-port hub. That is, the other side of this hub, it's going to be one cable or one link, one coaxial cable or one Ethernet cable coming up. And this side you have four links are getting connected. So four stations can be, or four end users can be connected here. Next topology is bus topology. So bus topology is nothing but you have a common link and it is possible for you to take a tapping from the link. And this, it's something like a water pipeline. So what we construct for our houses, water pipeline, you will have a common pipeline, and from the pipeline for each houses you can take the tapping. So similar to that, you have a common cable, and from this common cable we are taking tappings for each devices. So this is called as bus topology. Next we move on to ring topology. So what is ring topology? How does it look? So ring topology is nothing but it is like a cycle. So it's something like two buses connected together, two bus topology connected together. So you are having some repeaters. So these repeaters are basically used for signal conditioning. Whenever there is a signal losses because of the distance the signal is traveling in the link, sometimes some degradation might happen based on the medium what you use. So there is a necessity for you to boost up the signal. So we use repeaters for that purpose. So this is the structure of a ring topology. And then what we have here, so we have something called as hybrid topology. But though we have four different topology, but coming to real-time environment, constructing a network in real time, we may not be exclusively using each topologies. Sometimes we may require to use a hybrid topology. So this diagram shows you two topologies. So you have a star topology. Please see that you have a hub, and from the hub you have a star topology coming up. And in the star topology, you're taking a bus topology. Yes, you're taking tappings, and that is your bus topology. So similarly, according to your requirement of the application you want to construct in real time, the hybrid combinations can be varied. Yes. Next, we move on with networks. So networking, as we said, connecting multiple nodes to form a network, or multiple nodes you are trying to connect. But what way you want to connect, we have seen as a topology. Next, we can see that based on the kind of distance you want to formulate a network, or based on the interconnectivity you want to provide, we have three kind of networks. One is called as a local area network, shortly called as LAN. Second one is wide area network, WANs, and metropolitan area networks, MANs. So local area networks will have short distances and they are designed to provide local interconnectivity. So this kind of network you are able to see in as an education institution, as student sector, we are able to see in all your laboratories. In an office environment, we are using LANs. The second category of network what we have is wide area network. This is a long distance communication. It's a long distance network and it provides connectivity over a larger area. Simply, I can say a cellular communication can come under wide area network, where you have a base station and that is providing a longer coverage and as well as a longer connectivity, covering a larger area. Third category, what we have is metropolitan area network, which I shortly called as MAN. As we said, it is providing connectivity over areas such as city and campuses. So these are the types of or categories of networks. So then we have a simple illustrative LAN. So you have an illustrative diagram that shows how a LAN could be. As I said, could be in your office setup or in your institutional lab setups. So you can have some rows of computers that can be connected, and in each row can have some kind of number of nodes. Again, this is a hybrid topology we can of. Hub. This is a small scenario showing you how a real LAN will look like. In some cases, in case of a wide area network, as illustrated in the previous session, we can either use a point-to-point or point-to-multipoint. So here you have a point-to-point WAN. So a computer connected to a modem, then to a point-to-point WAN, and then to a ISP, which is Internet Service Provider, which we are going to discuss in the next session. And coming to a switched WAN, So you have n devices. So based on the number of n devices you want to connect in a WAN, so you can have a switched WAN. So these are actually switches, which are also another interconnecting device, such as like a hub, which we will be discussing in the subsequent modules. Okay, so this is a small scenario illustrating what is the difference between a switched WAN and a point-to-point WAN. Next, we have the kind of hierarchy, or I can say the heterogeneous network, what we try to have in real time. Heterogeneous network is nothing but formulating a network with different technologies. So this is an illustration diagram that shows you are having a network formulated with WANs and LANs, which are two different technology. So this LAN is basically using a bus topology, whereas this is using a star topology. And these two LANs are connected to the WAN by means of your routers. So router is also another interconnecting device. So the number of routers you want to employ between the LAN and the WAN depends upon the distance you want to cover. It could be either a point-to-point WAN or a switched WAN. And from the switched WAN, you can have, so whether choosing a point-to-point WAN or a switched WAN depends upon the scenario in which you are trying to connect the network. Okay. So to give a summarization of this video, we have seen what is the meaning of topology, what are the various types of topology, how are they connected, and what kind of hybrid topology that can be made in practical scenario construction, and what are the various types of networks, as well as how these topologies are employed in the networks. So thanks for watching. Keep updated with the upcoming videos. Thank you very much.